Morning everyone. Welcome you to the course of Advanced Power System Protection. Before I start the course, let me wish you a Happy New Year 2023 and also a happy learning ahead. Coming to the course of Advanced Power System Protection, the introduction has already been provided for you in the course introduction video. So in unit number 1, we'll start with a brief description and function of digital relaying and digital relays. And before I start the concept of digital relays, let's have a quick look about the relaying and the historical developments in the relays. I hope that this lecture will improve your knowledge on the relaying concepts. Why do we need relays in power systems, and why we should go with digital relays. So I hope that by the completion of this lecture, you will be able to state the need for protection of power systems and also state the significance of digital protection. Coming to the contents, I will just have a quick review about the introduction to the relay. You might have already come across this in your course of ESP, Power System Protection, in your 7th semester. And next, we will also see desirable qualities of relay. I think this has also been covered. And classification of relays. I think up to this part you have covered in your previous semester. But let's have a quick review. And after that, we will see the evolution of relays. And finally, I'll close it with the futures of digital relays. Coming to the stats. As you all know, a relay is an automatic device which senses any abnormality in an electric circuit. Abnormality in the sense it can be anything which is undesired. Maybe it can be overcurrent or voltage or any changes in frequency or power, or maybe direction of current is also which is undesired. So anything which you feel is undesired and that is happening in the power system, that can be detected using a relay. So a relay is just a device which senses any abnormality based upon its construction. And this relay, it provides a signal to the circuit breaker to open or close its contacts, thereby protecting the circuits by disconnecting the faulty portion of the circuit. So let us see a quick, maybe this is a generator representation and maybe there is a load, let us suppose. Now I am employing circuit breakers here. So I will employ relays here. Let's see which type of relay and how many relays and where to locate and how to determine this location. This is all you might have studied in your previous semester. So let us suppose if any fault has occurred here and which is resulting in a heavy current, the I has suddenly increased, then automatically this, if you employ a overcurrent relay here, then automatically it senses that the current is very high. So immediately it sends a signal to the corresponding circuit breaker depending upon your connection. Let us suppose if you have given the connection to this one, then automatically it gives a signal to this circuit breaker. So immediately what happens? It opens the circuit, thereby protecting your generator. If the signal is sent back to here also, then automatically this line will be open circuited by the circuit breakers. So sensing part is done by relay, whereas circuit opening or closing is done by the circuit breakers. So a relay is a very simple device which senses abnormality, any abnormality as mentioned here. Depending upon your requirement, you will design a relay and implement it in your electrical power systems. And this helps you in protecting your equipment from any faults that happen in the system. Now, this is one more thing which we might have already covered. So let's have a quick look about the desirable qualities of a protective relay. The first one is a selectivity. The first one is the selectivity of the relay. which you might be knowing the things that it must be very selective on determining which fault it is going to operate. Discriminate. It must be clearly able to discriminate whether the thing is a fault or not. Maybe a small rise in current should not be treated as a fault in some cases. So your relay must be able to discriminate whether it is a fault or not. Stability. Your relay must be stable enough. And sensitivity. Sometimes you may require your relay even to sense a very small change in current also. So your relay must be ready for sensing even small amounts of abnormality. Reliability. Reliability means if you trust that relay that it is going to protect your power system n number of times, then your relay must operate n number of times. So it's a reliability, which means that it is not going to fail your confidence. The next one is speed. This is one important thing which a relay must hold. Your relay must be fast enough to sense abnormality and send the signal to the circuit breaker. The quicker it is, then automatically the more protection you will be having for your power system. And finally, the power consumption. Everybody wants their relays to consume low amount of power. You don't need any auxiliary devices to power your relays. That is what the desire of any user. So the preferable thing is your relay must have very low power consumption. That is a desired quality. And finally, security. If you are employing digital relays or numerical relays, you should ensure that your data is completely secure. So these are the desirable qualities of protective relay, even though there are so many things, but let us confine ourselves only to these desirable qualities. Moving on, these are the classification of relays. I think you might have gone through this one also. Classification of relays. Relays are hundreds in numbers. It's very tough to classify the relays. You can classify the relays based upon different parameters. So based upon the parameters, these are the parameters based upon which you can classify the relays. You can see the characteristics. How do you classify the relays based upon the characteristics? You can choose an overcurrent relay. See, an overcurrent relay basically has different types of characteristics, isn't it? Some do have definite minimum time, some do have inverse characteristics, some do have very inverse characteristics, right? So based upon the characteristics, most of the times it will be speed versus current for overcurrent relay, time of operation for overcurrent relay. You can classify the relays based upon. The second thing is logic. What type of logic you are going to include in your relays. So based upon that, you can classify the relays. The next thing is actuating parameter. Actuating parameter, so this is one of the thing which is generally used to classify the relays. So on what basis you are employing your relay? Maybe they are working based upon your current in the circuit. Maybe they will be working based upon the voltage in the circuit. Sometimes you will be measuring the impedance, and based upon the impedance your relay might be operating. So based upon the actuating parameter, you can classify the relays, whether it is V or I or power or direction of the current or impedance. So the actuating parameter is one of the things which is generally employed for classification of relays. The next thing is operating mechanism. You can classify the relays based upon the operating mechanism also. You can see electromechanical relays which do employ mechanical parts. You can have static relays which do employ transistors, diodes, etc. You can have microprocessor based relays which do employ microprocessors. You do have numerical relays. So operating mechanism may change. So based upon that you can classify the relays. And finally, application. Based upon the application, whether it is for which devices you are employing and for which function you are employing differential relays, distance protections. For transformers, Buchholz relay. So based upon the applications also, you can classify relays. So I want to clear one thing for you. See, as I have mentioned, based upon the operating mechanism, how many types you do have? You can have electromechanical relay, static relay, digital relay, numerical or digital relays, microprocessor based relay, right? This is the classification based upon the path which you are employing. And coming to actuating parameter also, based upon the characteristics also, you can have overcurrent relay, you can have differential relay, you can have distance relays. See, overcurrent relay, in that there are, let us suppose I'll take an IDMT relay. An IDMT relay, if you classify the relays based upon the characteristics, it has inverse definite minimum characteristics. A little bit inverse characteristics. These IDMT relays can be of electromagnetic type, static type, numerical type also. And they have an actuating parameter of current. If you want, you can convert that current into some voltage also, and you can employ here. So it doesn't mean that the relays are classified based upon only one thing. Relays are, an IDMT relay can be of EM, static or digital, and it can be used for any application also. So if you do have one static IDMT relay based on transistors, employing or current measurements, then this is one particular description, which means that it comes under static relays here, it comes under current, it comes under IDMT. So based upon this, you need to be more specific when you are choosing a relay. It depends upon your application. So as already mentioned, there are so many relays. You can choose among them based upon your requirements. And this is just a slide which just shows you the classification. Now we will move on a little bit ahead. The relays. Relays were first started in the 18th century. They progressed in the 1900s onwards. And the very first relays which came into picture were electromechanical relays, which were called as a first generation relays. And in 1963, we have got this solid state relays, which do employ the electromechanical relays. Basically, they employ moving parts, and they work on the principle of electromagnetism mostly. Mostly they employ electromagnetic principle, electromagnetic attraction or repulsion principle. And in 1963, we have got this concept of solid state relays. And next, after this, the first solid state relays they used to employ diodes, and next came the transistors, and next came ICs, etc., etc. So these were called as a second generation relays, or we call them as analog relays. Later, in somewhere in 1970s, we have started using processors, microprocessors, and still advanced microprocessors came into picture. We call them as digital relays and numerical relays. So based upon this slide, all these things which do employ moving parts, I have classified them as first generation relays or electromechanical relays, and which don't employ any moving parts, which do employ this ICs, etc., then I'll call them as solid state relays. So your static relays, digital relays, numerical relays, all these they do employ these type of ICs. The only difference is that it's a complexity of IC which you are employing. This static relays, they do employ only simple diodes and transistors and ICs, etc. The advancement is a microprocessor. The advancement is the PC based relays. Now we have got intelligent electronic devices, IED, that I'll show you in the next slide. So the world is moving ahead with the advanced protections, which you call them as digital or numerical relays. Maybe in the future we'll be seeing completely IEDs, intelligent electronic devices, for sensing of the faults. The electromechanical relays have now been, they are on the verge of extinction nowadays. But still there are some applications where you can see the electromechanical relays. This particular unit is all about digital relays. So it's just about how a digital relay works and what are the important components in that. So rather than moving into construction, I'll just We will have a discussion in the class why we should go with numerical relays or digital relays and what will be there actually in the digital relays. Okay. So moving on to the next slide now.